Hello and welcome to IEEE Soft Robotics Podcast. In this podcast, we're going to interview researchers from both academia and industry about their work, thoughts, spectrum, and more beyond that. This is Marwa Edwini, and I hope you will find this podcast useful. If you would like to connect with us, simply send us, and we will be happy to hear from you. And here is my interview. Thanks.
Hello and welcome to IEEE Robotics Podcast. Hello, Professor Albi. Thanks so much for joining us in the podcast. Such an honor to have you.
Having me. Thank you for having me.
Thank you. I would like to ask you first, how you would like you to define yourself, maybe for the audience, or maybe first time listening to you. How would you like to define yourself?
Well, my profession is astrophysics, but I'm still maintaining my childhood curiosity, and all the labels that I have right now are not so relevant, actually.
Mm-hmm. Wonderful. So going back to childhood, we have a signature question about the childhood. And we ask how childhood plays a significant role in your curiosity. And do you have any memories about your childhood?
Yeah, in two ways, the childhood shaped the way I am right now. One way is that I was born on a farm, and I used to collect eggs every afternoon and drive a tractor to the hills and on weekends and read philosophy books. And so that put in me two traits that I share right now. One is the connection to nature. I feel much more connected to nature than to people. I'm not a social animal. I don't have any accounts on social media, and I don't care how many likes I have on Twitter. I'm pretty much paying attention to the evidence that we get from experiments, data, and from observing the universe. I jog every morning at 5 a.m. and enjoy the company of ducks, rabbits, and birds much more than the company of people. So I'm sort of independent in my thinking and connected to nature. And the second trait came from the philosophy that I was very interested in at a young age, and simply it asks the biggest questions about our existence. And I was driven into astrophysics later on by circumstances, and realized that astrophysics is actually, even though it was an arranged marriage, so to speak, it was my true love, because in astrophysics we can address some of the deepest philosophical questions, like how everything started, what happened in the early universe, and how did the things we see around us today came to exist. And we can also ask, so that's setting the stage, so to speak. And then we can also ask, how did we come to exist as living creatures here on Earth, and how, we are born into this world and as actors. And the question is, who else is around, and the other actors around, and are we the only actors in our neighborhood, or are there smarter actors? And that's the question of my new book, Extraterrestrial.
Yeah. So first of all, congratulations for your new book. But maybe because we are from robotics community and we're curious about, we saw you in Joy World, for example, and Brian Keating, you speak about the Oumuamua phenomena, and whether it's from alien technology or artificial origin, or maybe from natural phenomena. If you can tell us about Oumuamua in 2017, for people who maybe first time outside of your field, what's actually is? Why do you think it's maybe artificial origin, or
Right. So Oumuamua was the first object that we spotted near Earth that came from outside the solar system. And we call it interstellar because it came from outer space. We don't know where from. And at first, astronomers assumed that it must be a rock of the type that we have seen before in the solar system, bound to the sun. But this one, of course, came from another star. Then as more and more data was assembled on it, it looked like it doesn't seem to be a comet. It didn't have any cometary tail. No gas was evaporating from it as a result of the warming by the sun. And even the Spitzer Space Telescope looked very carefully around it, couldn't detect any carbon-based molecules. So it was definitely not a comet. But then it showed some other peculiar facts. It was not a rock, an asteroid, because it exhibited an excess push away from the sun, most likely due to the reflection of sunlight. And its shape was quite extreme as it was tumbling. The variations in light was the factor of 10, and that implied an extreme geometry, most likely pancake shaped at the 90% confidence. So it was a flat object with an excess push from the sun, and I interpreted that to mean that it's the reflection of sunlight that gives it the push. And for that to be effective, the object needed to be very thin, sort of like a sail. And nature doesn't make sails. And so the suggestion came about that perhaps it's of artificial origin from another civilization. I should say that in September 2020, just a few months ago, there was another object detected by the same telescope in Hawaii, Pan-STARRS. And by the way, this object that I was talking about was given the name Oumuamua, which means a scout in the Hawaiian language. And so this new object that was discovered just recently also exhibited an excess push away from the sun without a cometary tail. It was given the name 2020 SO before anyone knew what this object is. And then astronomers realized that it actually came from the Earth. It was a rocket booster from a 1966 launch of a lunar mission, Lunar Lander Surveyor 2. And obviously it had thin walls and it was hollow, and that's why the reflection of sunlight gave it an excess push. It had a large area for its weight. And we know that we produced this object, it's artificial. We just don't know who produced Oumuamua.
That's interesting. Before going to the controversy, because I think that's a very interesting part, what do you think is the purpose behind it? If you let your imagination to, what's the purpose, do you think?
Right. So to figure out the purpose, you really need more data on an object. It would have been wonderful if we could have a photograph, or we could land on such an object and explore it. But we didn't, because it caught us by surprise. It was too small for its distance, roughly the size of a football field, at a fraction of the distance to the sun. And our telescopes cannot resolve it. But in terms of the facts that we know about it, there was one additional strange fact, and it came from a special frame of reference. It's called the local standard of rest. It's the frame that you get to when you average over all the motions, the random motions of stars in the vicinity of the sun. And it's sort of like the local parking lot. And this object was at rest in that local standard of rest. It was sort of like a buoy sitting at rest on the surface of an ocean, with the sun being a giant ship that runs into it. And so the relative motion of the sun and this object was just the motion of the sun relative to the local standard of rest. And, you know, you may ask, why would, I mean, only 1 in 500 stars are so much at rest as this object was. So it's extremely rare to find an object that is at rest in the local standard of rest. And you might ask why. And one possibility is that it's a member of a grid of objects that are used for navigation purposes, to know your coordinates in interstellar space. Or maybe it's a relay station for communication purposes. We don't know. I think the best thing to do is, next time we see another object like it, and there should be more in the coming years, because only after observing for a few years with the Pan-STARRS telescope, we found this object. So we should find more every few years. And in fact, in 3 years, there would be a new observatory called the Vera Rubin Observatory, much more sensitive than Pan-STARRS, that could find an object like that every month. And when we see a weird object of this type, we can send a spacecraft with a camera that will intercept its orbit and get a close-up photo, because they say that a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book.
Okay. Maybe I just ask you, because, for example, Neil deGrasse Tyson, when I saw his comment about this phenomena, he said that we don't have to jump for conclusion, it's alien technology. And some people say, why do you think we believe in that? What could be the gain or the benefit for humanity if we know there are more intelligent species on other planets? So why do you believe in that? And why you think that we don't have to jump to this conclusion? So it's real to happen?
Well, the way science is done is when you have anomalies of this type, when there is some observational evidence, you have to explain it. Okay, that's the way science is done. It's not just saying, I don't think so, I do think so. It's not a matter of opinion. What you need to do is explain the facts. And other than the artificial origin, the light sail hypothesis that I was talking about, the reflection of sunlight as the source of the extra push, there were three other possibilities put on the table. And so we just need to look at them and decide which one looks more plausible. The point is you need to explain the anomalies. And so the three possibilities that were put on the table in addition to an artificial origin, one was that it's a hydrogen iceberg. It's a chunk of frozen hydrogen, so that when you get a cometary tail from that, when the hydrogen evaporates, you won't see it because hydrogen is transparent. We've never seen a hydrogen iceberg, by the way, and we don't know whether such things are produced in nature, in molecular clouds. But at any event, the problem with this proposal is that the hydrogen iceberg would evaporate very quickly along the journey. We showed that in a scientific paper, that it wouldn't survive interstellar space because it would absorb starlight and evaporate very quickly. So that is not a viable possibility. Then there was a suggestion, maybe it's a cloud of dust particles, very porous, very rarefied, 100 times less dense than air. And of course, the problem with that is when it gets close to the sun, it will be heated by hundreds of degrees. And it's difficult to imagine how a cloud of dust, like a dust bunny, that is 100 times less dense than air, will maintain its integrity, given its relatively weak material strength. And so then there was a third suggestion that maybe it's a fragment, a piece of a bigger object that was disrupted when it passed close to a star. And the problem with that is usually you would get an elongated cigar-shaped fragment rather than pancake-shaped, as inferred from Oumuamua. So all of these alternative proposals have flows, deep flows. And so it's not just a matter of Neil deGrasse Tyson saying this or that. It's not politics that we are talking about. There are some anomalies that were observed and you need to explain them. That's the way science is done. And to me, given the alternatives, the artificial origin is a viable possibility. It needs to be put on the table. I'm not saying that it must be the case. I'm just saying that all possibilities that were entertained involve something that we have never seen before. And so the obvious conclusion from that is, let's collect more data on future objects of this type. Let's get a picture. The only reason we will not get a photograph is if everyone says, oh, it's a rock, forget about it, business as usual. That's the only way by which we will not know much more about it. And, it's very similar to the way the philosophers reacted to Galileo. They said, we know that the sun moves around the earth. We don't need to look through a telescope.
That's very interesting, Bart. Maybe I could ask you first, why do you think there's maybe this kind of maybe bias or maybe academic community sometimes, not even in your field, but I think in general, there's a conservative approaches that you don't have to go for risky ideas or different explanation. From your experience, so how do you feel about that?
Yeah, so that's very common in the current academic culture, and especially in physics. And it's unfortunate because it suppresses innovation. And one reason for that is that people worry about taking risks, putting skin in the game and getting into what they might regard as a controversial discussion. But think about ancient history when humans used to argue that the body has a soul and therefore anatomy should be forbidden. Imagine if scientists would say, oh, it's a controversial subject. Some people claim the human body has a soul and others dispute that. We don't want to discuss it, the human body. And then where would modern medicine be? I think it's an obligation of science to actually address questions of importance and interest from the public using the scientific method and clear them up rather than shy away from them. But the reason that it's not attended to this subject, even though the public is extremely interested in this question, and the testimony for that is the success of my book, which is a bestseller in many countries a week after appearance. So the reason that scientists shy away from it is because there is some risk involved in talking about it, and they want to maintain an image where they have a good reputation and get honors, awards, and so forth. And the problem with that is that it brings the practice of science into a safe place, the comfort zone of scientists. And that's not the right place to be in, because if you think about quantum mechanics, one of the pillars of physics that was discovered a century ago, it took physicists out of their comfort zone. And Albert Einstein resisted the notion of spooky action at a distance, but he was wrong. Turned out that quantum mechanics has spooky action at a distance. We know it from experiments. And so the comfort zone of scientists is not the place to be in. Now, what it does is bring some scientists to even not want to have to be engaged with experimental verification. So you see these cultures of string theory, people that invoke the multiverse, extra dimensions, supersymmetry, things that do not stand up to any validation from experimental data. And the reason it's very comfortable, you may ask, okay, if the community is so conservative, how come it discusses extra dimensions? That's mainstream right now. Well, the answer is because it's a safe zone. It's a place where you can be and demonstrate that you are smart without putting any skin into the game, without risking yourself. In fact, it's better than areas where you have experimental tests, because you're at no risk of being proven wrong. And so that to me is the motivation. People want to maintain their image and do not want to be proven wrong, and therefore they shy away from experiments. At the same time, they are ridiculing discussion on something that is basically related to evidence, the possibility that Oumuamua is a technological signature. And I think it's unhealthy. This state of affairs is unhealthy. And I very much hope that it will change. I wrote my book, by the way, for the young generation, with the hope that without prejudice, they will fill the halls of academia in the future and bring a new spirit that is more risk-taking. And, science is supposed to be exciting, not boring. We are not supposed to repeat what we already know. We're supposed to explore new things. And there is no way of doing that without taking some risks. That's well known in the commercial sector.
I really would like to thank you for this point, because I think it's not only limited to physics. I think in general, I don't know what you think about what could be approaches. Of course, in your book, you try to instill this for younger generation, but what could be maybe realistic approaches so that we can change way of thinking, that because we have funding, and if you have a risk, and if you are still starting career, you don't have to go to risky, because I can imagine how it's stressful, to have this all people.
Yes, it is definitely stressful, and there are two ways that I see a path forward. I mean, I don't expect, just like we couldn't expect Marie Antoinette to endorse the principles of the French Revolution because she benefited from the previous system. She wouldn't endorse. She suggested that people eat cakes if they don't have bread. That was the famous statement. So I don't expect people that benefit from the current system to embrace the new principles of, putting skin in the game and testing their predictions and possibly, being wrong. But I hope that the younger generation will bring back the healthy state of affairs that used to characterize physics and science and the academic culture in the past. And by the way, that's the whole purpose of having tenure, that you are not worried about your job prospects, and you are able to go into innovative ideas. And it's really ironic that people get tenure and then become even less risk taking, more risk averse, just in order to gain honors and awards. This is really not what it was meant to. And the way I think we could change the culture, other than bringing young people with a different approach, is by rewarding people for taking risks, by rewarding those that are innovating, rather than those that maintain the old traditions. And the way that funding, for example, takes place right now is based on selection committees that are populated by those same people that maintain the current culture. And obviously the funds are not allocated to risk-taking or innovation. And one way that scientists often justify it is say, oh, it's taxpayers' money. We should use taxpayers' money in a way that, will not waste it. But in fact, the commercial sector has a completely different approach. It's clear that if you take risks every now and then, you would be successful, and that would actually give you much greater benefits because you will discover new things. And so I think that the conservative approach of investing only in things that you can forecast in advance what they will give you is actually accomplishing the opposite. It is wasting money on things that we already know. And so I very much hope that a new approach to funding with a certain portion of the funding allocated to innovative proposals would be adapted. But even if the federal agencies cannot accomplish that because the scientific community is filling up the selection committees and therefore suppressing risk-taking, even if that's the case, perhaps the private sector, perhaps the wealthy individuals, there are many of them right now, would, aside from trying to make a profit, would invest in fundamental research and allow innovation in this way.
That's a good point. Thank you for saying that. I'm curious to ask you what something is still hard to understand. Maybe when you have this Oumuamua in 2017, and lately you also saw Big Killer in September 2020, but something still hard to understand. When you let's think about it, what something is still hard to understand?
Yeah, so well, first, so there are, in the case of Oumuamua, there were some anomalies, as I mentioned, that each of them could be a 1% chance, that it's a rare outlier in the population of objects. But then when you multiply 6 times the 1% probability, you get 1 in a trillion, which makes it extremely unlikely. And, so why would the first object show up and come from such a rare tail in the distribution of possible objects? That was the thing. And to me, the most unusual anomaly was the excess push away from the sun that was not associated with any cometary activity on this object. And of course, as we get, if the object is really a technological piece of equipment, then when we take a photograph of it, we will see many more strange features. And if we decide to land on such an object, we can learn about the technology that is far more advanced than we have. And so the more information you get, the more questions you can ask. At the moment, the information is very limited. But what I'm suggesting is a different way of searching for technological civilizations. In the past 70 years or so, we search for radio signals. And that is like trying to have a phone conversation. You need the counterpart to be alive when you have the conversation. But for example, the Mayans are not alive anymore. They're not around. We cannot have a phone conversation with them, but we can learn about the Mayan culture by searching for the relics it left behind in archaeological digs. And we can do the same thing through space archaeology. In fact, it turns out the sun is a latecomer. Most of the stars were formed billions of years before the sun. And so if they had civilizations like ours that developed technologies and launched them into space, we could find equipment that fills space, even if the civilizations are dead by now. And most of this equipment will be billions of years old. Just imagine Voyager 1, Voyager 2, New Horizons. These will not be functional a billion years from now, but they would still provide a symbol of a civilization that existed, ourselves, that sent them. And so it's a completely new frontier that can be opened. And I think that space archaeology should be as mainstream as archaeology on Earth is. So every campus should have, potentially a group of people working on space archaeology. Why not?
That's interesting. So I'm curious to ask you, if we are not alone, I don't know if you think how much does it take to answer this question, whether we are alone or with other people or other species and other planets. So what does it take to answer this question?
Yeah, I don't think it takes too much. Right now, there is very little funding at the level of hundreds of thousands of dollars to the search for technological signatures from federal agencies, and that is a factor of 1,000 less than other frontiers in astrophysics, like the search for the nature of the dark matter. We don't know what most of the matter in the universe is, and there were various conjectures about specific types of particles, and hundreds of millions of dollars were invested in searching for them, either in laboratory experiments or in the sky. We haven't found evidence for the dark matter. It's not a problem, but one thing to recognize is the dark matter nature will have zero impact on our daily lives, because who cares if it's an axion or a weakly interacting massive particles? It wouldn't have any effect on us. However, if we find that there is another civilization out there and they are smarter than us, it would have a huge impact on society. It will change our appreciation of our place in the universe. It will change our aspirations for space exploration. It would change the way we think about our future, about religion, a lot of things, how to communicate with them, what can we learn from them. A lot of issues will come up, and there is no question that has a bigger impact on society, I think, than finding that we are not the smartest kid on the block. Nevertheless, very little funding is allocated for this, and I find that very strange, because the public funds science, as we said before, the taxpayers' money, and so how come the scientists are not responding to the interests of the public? And not only that, but ridiculing this subject. And not only that, are supporting cultures of scientists that are not even engaged in an experimental verification. So something is really wrong right now in the intellectual culture within academia.
Absolutely. I agree with that. Yeah. So maybe someone could argue about whether what you do, maybe lead to nothing. Maybe we can make a mistake. And how do you see the committing mistakes in general? Because people sometimes say that committing a mistake is not allowed even to do mistakes.
Oh, no. I mean, Albert Einstein was wrong 3 times at the end of his career, the last decade. He argued that black holes don't exist, gravitational waves don't exist, and quantum mechanics doesn't have spooky action at a distance. And the thing to recognize, I mean, all 3 were verified. He was shown to be wrong on all 3 counts from experiments that took place later. And the lesson from that is that when you work on the frontiers, you might be wrong because it's never clear which path to take. But it's part of the experience, and kids are not worried about bumping their legs into objects and in learning about how to behave. And that's called putting skin in the game. That for them it's literally speaking, they actually get bruised. But for scientists, it's a way of learning about the world, but by comparing predictions to data, to clues, to evidence. And that's the way we learn. And it's not about us showing that we are smart. It's about a dialogue with nature, trying to learn about nature. And we should be humble and modest. What we know is very little. We are such small partners in the universe, we are such a small component. How can we be arrogant and believe that we know in advance what the truth is? When people try to argue that we are the center of the universe, that was very flattering to our ego, but turned out to be wrong. The earth moves around the sun, as Galileo was arguing. And the fact that philosophers didn't look through his telescope didn't change anything. It just maintained their ignorance, and reality doesn't care whether we ignore it. And so my point is simple. It's to our benefit to get as much information about our environment, including, who else, other civilizations out there. It's to our advantage so that we'll get a more realistic picture about our place. And therefore we should explore it. The LIGO experiment that discovered gravitational waves required $1.1 billion. Without this investment by the National Science Foundation, we would never discover gravitational waves. So you can't say, okay, let me put just $100,000 and see what I get. And if the evidence is not extraordinary, then I wouldn't even believe in the possibility that there is alien life. Well, that's not the way to do it. You need to invest $1 billion at the level of the LIGO experiment, and then you would have a good shot at seeing something. And my point is that without willing to discover new things, you will never discover them. And in the case of space archaeology, the next step, in my opinion, is to design cameras that will be deployed within the orbit of the Earth around the sun, such that when interstellar objects like Oumuamua that look weird come along, these cameras will get close to them and snap a photograph, and then we can tell what they look like. This would be the equivalent of doing space archaeology.
Mm-hmm. That's a good point. Yeah. I'm curious about that maybe influence for public, because I can assume how it's hard again, and it's a responsibility for you to do that by yourself. So I can imagine how it's hard. But how do you see now the influence for the direction of the project or the problem or the question that matters to people at the end of the day? And we don't have an equal number for ecologists and words and etc. for this direction, because it is hard how you can communicate with public.
It's very difficult, I should say, and painful for me personally, because people are attacking me without, and all I'm asking is to pay attention to the evidence. And the way I see, I mean, the only reason I'm doing this is because it's a very big question. You know, this is a question that is the most fundamental and the most, that will have the most impact on society if we answer it. And I just think the scientific community is exactly in the wrong place, and I'm willing to carry the consequences, you know, because I think it's so important to humanity. It's one of these big questions that will have a huge impact, and we cannot allow ourselves to ignore it. And indeed, the public resonates with my point, but the scientific community is not. And I'm even being attacked as if I'm saying something against the SETI community, which is exactly the opposite. I'm asking for them to be funded by more. So it's really difficult. And you know, when I was young at age 18, I served in the military, and I remember saying that a soldier sometimes has to put his body on the barbed wire so that others will pass through. And that's the way I feel. I really wish that the younger generation of today will have an easier time and will be able to discuss this subject freely. And I'm doing that by going through this process. But by no means it's guaranteed that I will be successful in changing the current culture.
First of all, I think what you do is with absolute courage to, even if it's right or wrong, but I think I appreciate that, because not many people are willing to do that. So thank you for doing that.
Thank you.
And we are closing to end and have a few questions. First one, what's your aspiration? You have a lot of success, and now have your book about explaining what he said in extraterrestrial. So what's your aspiration?
My aspiration is, of course, to find the answer to the question, are we the smartest kid on the block? And I really hope that I will live long enough to see evidence for that. And it would be amazing, because I think we will be shocked whether we find life, biological life from another planet, or if we find technological equipment from another technological civilizations, that would be shocking to us, because when you go to meet a person, it's a safe assumption to make that the other person would look similar to you, because you share the same genetic heritage. But when you meet life from another planet that had no contact with Earth, I'm not talking about Mars, because Mars exchanged rocks with Earth, but something much farther away that had no contact with Earth, then it could be very different. You know, when you open recipe books for cakes, you find that you can start from similar ingredients and end up with very different cakes, depending on how you mix the ingredients and how much heat you apply. And so I would think that we would be shocked to see life on another planet far away, because it would look very different from what we are familiar with. But in terms of technological equipment, we just started a century ago developing our technologies. And, I can imagine how would we be in the future, 1,000 years from now, 1,000,000 years from now, the technologies would be unimaginable from our perspective right now, and they would look like magic to us. Because other stars formed before the sun, the future of us could represent the past of other civilizations that developed technologies. And therefore, if we look at the sky and find those pieces of equipment, we might see our future, so to speak. And it will give us a jump start, because we can import those very advanced technologies to Earth without developing them ourselves.
Yeah, Yeah. Do you think we understand everything about universe? For example, we see that universe sometimes it doesn't make sense to us, and it takes a lot of time that we ask this deep question. So because life goes so fast, how do you see
Right.
maybe advice for how we contemplate about what around us? So
Yeah.
yeah.
So, we are born into this world like actors that are put on a stage without a script. Nobody tells us what our role is supposed to be and, what's the play about.
Mm.
And it's very strange when you are put on a stage. So, because for me as a scientist, the interesting ambition is to understand what is happening on that stage, who else is on that stage, and perhaps that will shed some light about the play that we are playing. If we find other actors, um, and of course you want to understand also what the stage is made of, and that's what astronomers and cosmologists are doing, trying to figure out what the universe contains and how it works, what is started from, how it evolved to where it is. But one thing is clear, that we are playing a very minor role, and that is the sense of modesty that I was mentioning before. We are sitting on one planet we call our home, the Earth. And not only that there are 10 to the power 21 such planets in the observable volume of the universe, more than the number of grains of sand on all beaches on Earth. And not only that we are not at the center of anything, but also the half of the sun-like stars have a planet roughly the size of the Earth and roughly at the same separation. So what we find in our backyard is very common. And so you realize, okay, you are an actor, but there are many there are many other places where the circumstances are similar. And so the next question to ask is, are there other actors? And that's the question I'm asking. And what is the meaning of life is of course the most important question. Is there any meaning? And obviously any meaning that we assign to it right now is on Earth. And in a billion years, the sun would evaporate, boil off all the oceans on Earth. So all the meaning that people usually give to their lives will go away in a billion years. It will not be forever. And it makes sense to try and figure out the bigger picture. What is there a meaning in the bigger scheme of things? And so that's the biggest question, actually.
That's fascinating. Yeah. And do you think ego is important? I know you organize that, but when it comes to have different ideas, different views, do you think ego sometimes is important for you to
Oh yeah,
defend?
not for me, but I do think that ego is suppressing innovation, because people in trying to promote their ego, their self-image and so forth, their reputation and so forth, they are avoiding risks, and they are also repeating what we already know, and they build echo chambers. Professors build echo chambers of students and postdocs that repeat the mantras that they were saying for many years, and that is only in order to make their voice louder and enhance their image, and that is motivated by ego. And I think it goes in the wrong direction of making science serve a purpose that it was not supposed to. I mean, the purpose of science is to understand nature, and that's a completely different objective. It involves a dialogue with nature. It involves making mistakes through this learning experience. It involves paying the greatest respect to evidence rather than to what we say in order to impress other people. It involves keeping your eyes on the ball and not on the audience. And that goes against the social media, where people just look at each other and see what other people say and just want to be liked by other people. That's not, I mean, the purpose of scientific inquiry. It's not to be liked, it's to explain the evidence that we have.
Mhm. That's a serious point. Yeah. And what could be the most important quality you have gained in this journey? Because it's also stress and passion, this mixing feelings. What could be the most important quality you
Yeah,
have to maintain?
for me, since the beginning of my scientific career, it was to understand something that nobody else understood, about nature. To try and, our knowledge is an island in an ocean of ignorance, and I'm trying to push to increase the landmass of this island. And so it was always to try and learn something new about the world. And I don't care so much even about things that I myself discovered or found. And I don't care about the past. I always look forward, sort of like a kid, you know, and because I'm looking for some excitement, intellectual excitement, not excitement coming from getting an award or another person saying something nice about me. That is not an exciting thing. What is exciting is something with substance, you know, some understanding something about the world that we didn't understand before. And that's what drives me, and that's what gives me more satisfaction.
And what could be something inspire you every day, keeps you to do what you do? What inspires
What
you?
inspires me is, interacting with nature. So when I go and jog, and you know, every day I see something new, and I do it at 5 a.m. So I see the sunrise, and every day the sunrise looks different. I must tell you, it's quite amazing. And also every day the weather is different. Sometimes I have to run in the snow. Sometimes I have to run in the rain. And that I enjoyed the challenge of doing that. And one day it was rainy, and I fell with my face on a rock, and blood was covering my face. I came home, and we had to be rushed to Mass General Hospital. And I spent the entire day until midnight at the hospital. But then the following day at 5 a.m., I went jogging again with bandages all over my face because I enjoyed challenges. And for me, you know, if life places a challenge, then I try to cope with it and overcome it. And that's part of the fun. But overall, it's, you know, the connection to nature that gives me the biggest inspiration, because you know, every time I go out, I see different things, and sometimes wild turkeys or other things running around, and it's just amazing to observe nature. And you know, we live for such a short time, just one part in 100 million of the age of the universe, on such a small rock we call the Earth, out of the vast space that is out there, that it's really, I would say, a lost opportunity if you were to just focus on what is happening around you rather than look at the big picture. It's really the big picture that gives you a peace of mind that, you know, whatever happens to you is not that crucial. You know, it's a sense of modesty. But also, if bad things happen to you and you see the big picture, you know, it elevates your spirit, it lifts your spirit, it gives you something, some inspiration. And, you know, Oscar Wilde captured it the best. He said, "We are all in the gutter, but some of us are looking at the stars."
That's insightful. Thank you for sharing that. Thank you. And lastly, what was best advice was given to you and was life changing? The best advice was given to you.
I would say that I didn't get good advice throughout my career, but for example, I was told to focus on a niche and develop expertise such that I would be the world expert in one subject. And it's exactly the opposite of the advice I would give to young people. I think seeing the broader picture offers benefits, because very often a narrow niche dries up after a while and you reach rock bottom, and then you don't know where to go from there. Also, sometimes it's not successful. It doesn't provide the fruits that you expected. And so if you have a broader view, you know what to do next and how to, and also if there is evidence that is not quite lining up with what you expect, you know how to interpret it because you have the broader view. So my advice to young people is to maintain their youth in the way they think throughout their life, and basically be less motivated by their ego and more by curiosity, and you know, be willing to take risks and innovate. That's the fun of doing it. You know, getting honors, awards, and impressing other people is not really as much fun as the substance in discovering something new.
Absolutely. Thanks so much, Professor Eve. It was a real pleasure and honor to have you on the podcast. Thanks
Well,
so
thanks
much.
for having me. It
I
was a
wish you
great pleasure speaking with you. Yeah.
Me too. Thank you.